Everyone, made it first. Alright. We gotta deal with yesterday's problem. We have to. Because it's fresh in my mind, so I want to deal with it. Alright, push dominoes and dominoes in a line. We place each domino vertically. But anyway, simultaneously push some of the dominoes either to the left or right. After each second, each domino that is falling to the left pushes the adjacent domino on the left, similarly on the right. When a vertical domino has dominoes falling on it on both sides, it stays still due to the balance. For the purpose of the question, we'll consider that a falling domino expends no additional force to the falling or already fallen dominoes. You're given a string, dominoes, representing the initial state where left L if the ith domino has been pushed to the left, R if it has been pushed to the right, and dot means it has not been pushed. Return a string representing the final state. So if it's right, nothing left. Has been pushed to the right. So basically this pushed to the right and this pushed to the left, and they meet in the middle. So this get cancelled. But this also, the first domino expends no additional force on the second domino. Oh, okay. So in this case, still left. So push to the left. So both are left. This leave it right. So this will push to the right, but this push to the left. So this will be standing still. Left, right. So this will be right, left, left, and then these two will stand still. So some rules. If we have on the left side, if we go left, it's always go left. So I can just keep going, right? Keep going. If I find the left, and then everybody else gonna be left. So if I push this into the queue, into the stack, now we have a left, that will pop. Everything pop will be left. Everything pop will be left. And this left, we don't have to do anything because it's not going to change. Okay, so now we have right. So I say right, I also push it in. So if I have dot, 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 then I get a right. Okay. Because you're falling to the right. So I push it inside because I don't know what's going to happen. So I right. In this case, right, I have right. So I push it in, right, push it in, and I have a dot. Also push it in. Now I have a left. So the left, we're going to check. Because the left can turn a dot into a left. So I can turn this into a left. I'm not sure. Oh, we can try to find pairs. So a left-right pair is a no operation, right? Because the left goes this way, right goes this way, so it doesn't affect. Only if we get a right-left pair. So, okay, so we want to find a right-left pair. So I go. I find a left. I don't worry. Right, I don't worry. And in fact, if I find a left, then everybody will be left. So yeah, so we get a left. We don't worry. We don't worry. And then we hit a right. Okay, so when we hit a right, and also right left is like concentrating, so it doesn't, the impact is not expanded outwards. So if that's the case, then go left to right, and then we find the first right, okay, and then I need to find the left, right, and then I need to find the left, and then if I go, if I have another right, then I swap to this one, and everybody else in between become R. So this is the rightmost, right? And I go. If I have dot, it's fine. If I have R, I'll replace it, and everybody will become R, and eventually I'll hit a left. Now, when we hit a left, it depends on if I have even or odd, right? If I have odd, then the center one will remain. Everybody else will become R and left, right? If I have even, then we have just R and the left. We don't have anything in the center. Once it's done, we have called dot. If it's a left, I wonder if we can like do it twice. You know, like do it twice. The first run is just to identify the R and L. Right? We just find the R and L and not really. I still think about a stack, right? A stack. I got dot. I got a left. I will pop everybody. Everybody is all left. Right? And then I don't push left in. And I go dot. And I have a right. Then I pop everybody, but I do not change how they are. They remain as dot. But now I have R. Now if I have a dot coming in, I check it's an R. Right? I check it's an R. Then I pop this, push this in, and turn this into an R. That is not true. Okay, so if it's a dot, I don't do anything. Yeah, that's the thing. Like if it's a dot, I don't do anything because I want to know if we can find another R. Okay, so if it's a dot, I just keep pushing. If I find an R, then what? Or we don't push. Yeah, if I have an R inside and it's a dot, I see it's R, I don't push. Right? I don't push. And then if I hit an L, then based on what's in between, I can compute which one should be left and which one should be right. Okay, that's possible. And once I handled all this, I also don't push L because there's no point, and I just pop this R. Maybe feel like you don't need to do a stack. You can just get like 2 pointers, right? You can just get 2 pointers. So we start from here, point here, and then 1 point, just keep going. If I hit the left, then this one will go through. We got everybody left. Right? If it's right, then I move the left here, and then keep going. Right? So it's pointing to. If it's pointing to in R, that's when we care, right? So I go. So I can point into a empty, point to a dot. And I go. So yeah, we basically we can point to 3 different things, right? We can point to a dot, we can point to a left, or we can point to a right. So if I point to a dot, I go. I hit a left, then I'll move this one forward and turn everybody into L, right? And then I will move forward, right? Move forward, and then this one will keep going. If it's an L, yeah, if it's an L, and yeah, if the high is an L, and the low was not pointing to an R, then everybody should be L. Right? Everybody should be L. And then if the high pointing to the high is looking for L, right? So a high find an L, and the low is not pointing to. So what you're saying is I go forward and look for L. Right? I go forward looking for L. But what about R? Because I want the low to point into an R. Right? So, okay, I go forward. If it's an L, then everybody should be L. Right, keep going. If I hit, yeah, if it's a dot, then the high just keep moving forward. So the high will stop at the L, then I check the low, or the high reach an R, right? If the high reach an R, then everybody should just remain as they are, right? Everybody remain as they are, and then we'll put the low into the R, and then I keep going. I hit an L, hit an R, then I shall move forward based on what I am right now, right? So, because the low can be pointing to R, right? The low will not pointing to L. If the low, if high is R, and then yeah, so we have these scenarios, right? So high can equal to dot. If high is equal to dot, just continue. Okay. Now high can also equal to left. And then we can say, is low equal to dot? If low equal to dot, then everything becomes L. and then low equal to high plus 1. Okay, or low can equal to R or L. If low is an L, it's the same. Or low is R, then we do this, right? And then low equal to high plus 1, the same. Now if high is equal to R, so low can be a dot. If high is equal to R and the low is a dot, then all right. Yeah, so if I hit a R and the left is a dot, or a low is a dot, or if a low is a dot, then I should just move forward, or if low is a left, then nothing will happen, right? Then we just go low equal to high plus 1. Nothing happens. If low is an R, then everything become R, and then low equal to high plus 1. Yeah. Let's try. Yeah, I don't think I have Ghana to do the other one today. Well, if I can get hit this in one shot, maybe, but most likely not. All right. Actually, I have a lot of questions. String to vector. I like this one. So I can say vector of char vec dominoes dot begin, dominoes dot end. Okay, and then we have low and high. So low I set to 0, and high dominoes high plus plus. All right. So if dominoes high is equal to left, right? If it's equal to left, then it depends on if it's a right or if it's a if dominoes low is equal to a right. This is where things get interesting, but I will wait for it. Else is not, right? Low is not an R, then hold a second. I say if high is an R and low is a R, I shall move and this is moving it to high plus 1. Why did you move to high plus 1? Alright, so it's a R and move to high plus 1. What if it's a dot? Then I hit this, right? No, I think it should move to high instead of high plus 1. So we know what it is, right? Yeah, we should move to high. So we guarantee low is either L or R. Yeah, we guarantee low either L or R. Okay. So if else low is L or dot, because that's what's gonna happen in the beginning, right? Then it's a left, and then low is a dot or L. What we're gonna do is turn everybody into an L and say while low is smaller than high, vec low is equal to L, and then 1 plus plus. Until it hits, right? So this is the scenario where low is R, high is L. Then we need to know how many is in between, right? How many is in between? We actually don't need to know how many is in between. We can just do, I equal to low plus 1, j equal to high minus 1, right? While I is smaller than j, vec I equal to R, vec j equal to L. And then they will both plus plus. Yeah, that's that. Okay. So that's if now we have else if dominoes high is equal to R. Alright, so domino high is equal to R. And again, I need to check if low is equal to left, then we don't change anything, we just move. If low is equal to R, then everybody turns into R. So we say if dominoes low is equal to R, then we say while low smaller than high, vec low plus plus equal to R. Right, so everything's the same. Else is low is the left, so but then we don't do anything, then we say low equal to high. We move low forward. And at the end, let's say string stream ss, then for char c of vec ss dot append add. Actually, I don't know how string stream does. Because it's a stream. C turn ss dot string. That's my guess. My guess is as good as yours. But if going to the end, that's a good question. So the last R, right? High is R, low is R, and then everybody turns into R. If not, then we skip to here, and then we hit the end. Okay, so when we hit the end, we need to check. Yeah, we just check if dominoes low is equal to R. Because domino low is equal to left and nothing needs to change. Then I say while low smaller than dominoes dot size vec low plus plus equal to R. And then we do all this. I'm not sure. Let's give this a shot. See if it's right. Oh, my bad. That's minus. Well, that's pretty bad. I smaller than J. Ooh, yeah. So this coming here, this come here. But no, low should be here, high should be here. Right? Low plus 1 is this, high minus 1 is this. So I shouldn't even do this in the first place. Ah, I think I missed something. Yeah, I definitely missed something. After it's done, I need to move low. Where do we move? Low in this case. So high is at R, at L, low is at R. So we shall move. So low in this case because we close it, right? So low in this case shall equal to high plus 1, and move low directly forward. On all the other cases, I keep low at the high. Okay, try this one. Alright, they are right, but I'm actually not confident at all. This feels a little bit, I don't know. Oh, we got lucky. We definitely got lucky because I don't have confidence in this at all. Alright, I mean, okay, lucky, we got lucky. Let's see, in the past. Oh, we're pretty lucky all the way through. 2021, the first time we solved this, 2022, and on 2025. Alright. Adjacent symbols. Calculate force. Adjacent symbols. Between every group of vertical dominoes, we have up to 2 non-vertical dominoes bordering this group. Since additional dominoes outside this group do not affect the outcome, we can analyze these situations individually. There are 9 of them, as the border could be empty. Actually, if we border the dominoes by this, there are only 4 cases. Yes, so we shall do that. We'll write new letters between these symbols depending on each case. Oh, if we have an AB where A equal to B, yes. If we have this, then we do this or this. If we have this, so we don't do anything. So this is actually 1, 2, 3, 4 different cases. So what we're saying is I see. You add additional. Yeah, this is just, yeah, we add additional. And we just go through, right? We go through, we find pairs. We find pairs and then we change the inside. We find pairs, we change inside. That is actually not bad. That's actually quite smart, I think. Yeah, if the two are the same, then you populate with X. If it's RL, then you go meet in the middle. And if it's the other one, you don't do anything. And then just move index forward, right? Index forward, I have I, J, and a symbol. Okay, I don't understand this part. What the hell is this? Like, I would do it differently. Let me try it. I think this is a interesting idea. I'd like to explore. So this solution is inspired by the editorial. We add additional L and R to the left and right of the dominoes. Thus, there are only 3 of 4 scenarios of pairs, right? L L R L and R R, right? Each scenario can be analyzed just by itself. Each scenario is independent independent. So we can analyze them by individually. Okay, so in this case, what we're gonna do is std vector char vector char vec of size dominoes dot size plus 2. Okay, and we say, actually let's go n equal to dominoes dot size, and here we can say this is n plus 2. Okay, then we say vec 0 shall equal to a left, vec n minus 1 shall equal to a right, right? And then for a int I equal to 0, I smaller than n, I plus plus, we say vec I plus 1 equal to dominoes I. Okay, so that's how we do, and then we are gonna go low and high. Right, we're gonna go low and high. So high is going to start from here, and low and start from here, and then we are going to say int low is 0 for int high equal to 1, high is smaller than n plus 2, high plus plus. If vec high is equal to a left, right? And now we say if vec low is equal to a left, then everybody in between shall be, oh, that's actually very similar to what I was doing. Right, so for int I equal to basically low plus 1, right? I smaller than high, I plus plus, we say vec I equal to left. And once we're done, low equal to high, right? Else, the low is a right. So right, left, now we can say int I equal to low plus 1, j equal to high minus 1, while I smaller than j, vec I plus plus r j minus minus equal to left, right? And once we're done, we also get low equal to high. So low always will equal to high, so it doesn't matter. Right, low always equal to high. So this is when high equal to left. Now we can say else if high vec high is equal to low, not low, equal to r. Right. Again, we have if vec high, vec low is equal to r, and then we basically for int I equal to low plus 1, I smaller than high, I plus plus, then we do vec I will equal to r. Of course, it's gonna be plus plus. Right, and else there's no else. Else is left and right we don't do anything. Okay, and yeah, and then the end. So high will keep going, and high will hit the last. Right, high will hit the last. Oh, and this one also low and need to equal to high. Yeah. Like regardless, low will always equal to high. And high does keep moving forward. and then low equal to high, and then done. So once we're done, we can say std, just the same thing, string stream ss for int I equal to 1 smaller than n, I plus ss vec I turn ss dot str. All right, so this is borrowing the idea from the official solution. Let's see how it goes. That doesn't feel that much simpler. I mean, it's my implementation. Ooh, Lord. This is interesting. Okay, smaller equal to. Yep. I think you forgot. How? Because high hit high is starting from 1, but I don't do n plus 2, so right? So high will get to the last r. So we'll have a vec high equal to r, and vec low is equal to r. Vec low is equal to r, and vec low I is low plus 1, I smaller than high, I plus plus. And everything, wait, hold on. How? Huh? High shall be n plus 1, right? And low shall be... Ugh. I didn't have it. What? Zero, 1, 2, 3. High is 4. Wait, hold on a second. This is a 1, 2, 3, 4. Yes. 4. I is 0, 1, 2. I is 2. Perfect. Right? Perfect. Because it's a left to right, so nothing changes. So low equal to high. So low now become 4. Right? Oh, here is the error. I find it. I have found it. There we go. Small error. What? Dude. Huh? That doesn't make any sense. So low is pointing to a left, right? So hit R, and then this come in is R. Yeah. And then high keep moving, and a high hit another R. Then we need to fill up. It's the same question. Like, what the hell? Oh, my bad. Use this test case. All right, so 1, 2, 3, 4, 5, 6. Yes. 3, 3, 6. That's correct. 3 and 6. Right, 3 and 6. So low, 3 is R. So 3 is 4. Right, 4. What? Print debugging. I only get 4. I see. My bad. That is pure stupidity. Pure stupidity. I can't even express how stupid it is. It's pure stupidity. Unbelievable. There you go. Wow. No, this is slightly faster, I think. Alright, I want to also read the other one. Calculate force. Oh, net force applied. How close is to a left and a right? The closer we are, the stronger the force. I kind of remember this. So we find a force from left to right, 7. Scanning from left to right, our force decays by 1 every iteration, and it restores to n if we meet in R. So left to right, if we have an R, then we have a lot of force. Yes, the force I is higher than force J if and only if it's closer to R. So in this case, left to right, this is 7, 6, 7, 6, 5, 4. But we hit a L, that becomes 0. The force from right to left, that is minus 7, minus 6, minus 5, minus 4, 0, and 0, 0. Combining them, take the vector addition, we get this. So positive value is R, negative value is L. Interesting. Every time we hit, then we reset the power. Yeah, we reset the power. Interesting. All right, that'll be it.